On December 27, 2024, the world received a stark reminder of its vulnerability in the cosmic arena. Astronomers scanning the night sky detected a new visitor, a large meteorite designated 2024 YR4. Initial calculations sent chills down the spines of scientists and government officials alike. The data suggested a 2.3% probability of the space rock colliding with Earth in 2032. While this might seem like a small chance, it was enough to place 2024 YR4 at level 3 on the Turin risk scale, a system used to categorize the potential hazard from celestial objects. This marked the highest level ever assigned to a near-Earth object. The discovery sent shockwaves throughout the scientific community. Astronomers around the globe immediately trained their telescopes on 2024 YR4, hoping to gather as much data as possible. The world held its breath, waiting to see what fate awaited them. The clock was ticking.
As more data streamed in, a clearer picture of the threat began to emerge. David Rankin, an engineer at NASA's Catalina Sky Survey project, proposed a chilling theory, the Death Corridor. This corridor, a band stretching across the Earth's surface, represented the potential impact zones for 2024 YR4. The exact location of the impact, Rankin explained, would depend on the delicate interplay between the Earth's rotation and the asteroid's trajectory.
Rankin's analysis revealed a sobering list of potential impact zones. The northern tip of South America, densely populated areas of southern Asia, the bustling shipping lanes of the Arabian Sea, the African savannas, and even the vast expanse of the Pacific Ocean were all in the crosshairs. Countries like India, Venezuela, Pakistan, Ecuador, Bangladesh, Ethiopia, Colombia, Sudan, and Nigeria found themselves uncomfortably close to the death corridor. The world watched, waited, and prayed that the cosmic dice would roll in their favor.
The revelation of the death corridor galvanized the world into action. NASA, at the forefront of the global effort, immediately shifted its focus to understanding and mitigating the threat posed by 2024 YR4. A sense of urgency permeated the agency as scientists and engineers worked around the clock. The stakes had never been higher. One of the first steps was to gather more precise data on the asteroid's size, composition, and trajectory. This information was crucial for determining the potential damage from an impact and for developing effective mitigation strategies. Telescopes around the world were trained on 2024 YR4, tracking its every move.
In parallel, NASA began exploring various mitigation options. These ranged from kinetic impactors, essentially high-speed projectiles designed to nudge the asteroid off course, to more drastic measures like detonating a nuclear device near the asteroid to vaporize part of its surface and alter its trajectory. Each option came with its own set of risks and challenges, and the decision of which strategy to pursue would have far-reaching consequences. Section 4, a celestial hammer. Understanding the threat from 2024 YR4. Based on the amount of sunlight it reflected, scientists estimated that 2024 YR4 measured somewhere between 40 and 90 meters wide. While this may seem small compared to the vastness of space, an impact from an object of this size would be catastrophic.
The energy released upon impact would be equivalent to thousands of Hiroshima bombs detonating simultaneously. To put the potential destruction into perspective, scientists drew parallels to the Tunguska event of 1908. That year, a meteoroid estimated to be around the same size as 2024 YR4 exploded over Siberia, flattening over 2,000 square kilometers of forest. The blast wave was felt hundreds of kilometers away, and the night sky glowed for days afterward.
In the case of 2024 YR4, an impact over land could obliterate entire cities, causing widespread devastation and loss of life. An impact in the ocean would trigger tsunamis that could inundate coastal areas thousands of kilometers away. The economic and social consequences of such an event would be felt globally.
Section 5. Eyes on the skies. The James Webb Space Telescope takes aim. Recognizing the need for more detailed observations, NASA directed the James Webb Space Telescope, the most powerful space telescope ever built, to set its sights on 2024 YR4. The JWS, with its advanced infrared capabilities, held the key to unlocking crucial information about the asteroid's composition and structure.
The first observation window was scheduled for early March 2025. During this time, the JWST would focus on determining the asteroid's precise size and orbital parameters. These observations were critical for refining the impact probability calculations and for developing effective mitigation strategies.
A second observation window was planned for May 2025. This time, the JWST would track any changes in the asteroid's position and rotation. This information would provide valuable insights into the Yarkovsky effect, a phenomenon where sunlight can subtly alter an asteroid's trajectory over long periods.
The 2028 close approach served as a stark reminder that the threat from 2024 YR4 was not a one-time event. It highlighted the importance of continued vigilance and international cooperation in monitoring potentially hazardous objects in space. It would allow for closer observations of the asteroid's behavior and provide a chance to test deflection techniques. By closely monitoring 2024 YR4 during this close approach, scientists hope to gather valuable data that could help avert a potential disaster in 2032. Section 6. A harbinger in 2028, a dress rehearsal for disaster? As if the 2032 impact scenario wasn't enough, astronomers identified another close approach by 2024 YR4 in December 2028. This close encounter, while not posing an immediate threat of impact, presented a unique opportunity for scientists.
Section 7. Echoes of Tunguska, a stark reminder from the past. The discovery of 2024 YR4 and the potential threat it posed to Earth served as a wake-up call for humanity. It reminded us that we are not just inhabitants of Earth but citizens of a vast and often chaotic cosmos.
It underscored the importance of investing in space exploration, planetary defense, and international collaboration. The Tunguska event, a century prior, stood as a stark reminder of the destructive power that even relatively small celestial objects can unleash.
2024 YR4, with the potential to dwarf the Tunguska event in terms of its impact, forced humanity to confront its own mortality and its place in the cosmic order. The years leading up to 2028 and 2032 promised to be a period of intense research, technological development, and international diplomacy.
The world watched the skies not with fear, but with a newfound awareness of the challenges and opportunities that lie beyond our pale blue dot. The fate of humanity, it seemed, hung in the balance.